GSM-R and FRMCS will have to, peacefully coexist, as Paul mentioned earlier. So they've got to live together, and we've got to have a system that's going to be reliable, of course, and it's going to provide the capacity that we need. So the other project that's underway is project 2.0, and 2.0 is looking at hybrid FRMCS networks. So one proposal is to perhaps have on the train, so this will be the equipment that's taken on board by the railway undertaking. As I'm sure you are aware, with FRMCS, we separate the applications from the actual transport network. That gives them independence. But the applications will interface to this so-called FRMCS onboard gateway, and that then provides with connectivity through to our radio. Now, the radios are normally called UEs, user equipments, but quite commonly they're referred to as modems because they're going to be basically transmitting data from the actual train itself to trackside. So I've got one modem, one radio, and that's been fitted with a standard subscriber identity module, a SIM, that belongs to the infrastructure manager, so the organization that's built the FRMCS network. What we have on the right-hand side then is actually two networks. I've got the FRMCS network, which consists of the RAN, the radio access network, connecting through to the 5G core, and then we will route through to our trackside component, our trackside gateway, and access the applications. So it could be maybe a signaller's terminal on the right-hand side, and the signaller can actually set up a voice call through to the driver of a train, and this application will be supporting the voice communications. But to set that connection up end to end, it will involve using a mission-critical application server. So it will be a mission-critical push-to-talk application server necessary to set up those voice calls, and that will reside within the FRMCS network itself. What I've got in the diagram is I've got the actual network of a public mobile network operator. So here is his RAN using his licensed spectrum connected through to a 5G core. And what we're going to do is interconnect our 5G cores together over these standardized interfaces. So the idea behind this is if we lose connectivity with our FRMCS network, we can simply drop back onto an existing commercial network. So that concept will provide reliable radio coverage. It also protects us against failures in the FRMCS network, in the actual RAN itself. And the suggestion from this Franco-German project is that this is potentially an early likely option as we roll out FRMCS. It may also be possible to actually use network slicing in the public mobile network operators network as well to aid the actual process. However, there are some disadvantages. There's no protection against any failure in the mission critical servers, because there's only one of them, it would seem in the diagram. The public operator does not have one, and there is going to be service interruption. So if we lose connectivity with the FRMCS network, we are going to have to re-establish a connection with the public network, and that re-selection process will actually interrupt service. And we also need a national roaming agreement between the two operators. The second suggestion is the dual radio, but using different SIMs. So I've now got two modems located on the train. One modem is equipped with the FRMCS SIM, and the second one is the mobile network operator SIM. And I can then actually set up two connections at the same time. I can speak to the FRMCS network and the public network simultaneously. Notice this time we're not actually connecting the 5G calls together. There will be connectivity between the public mobile network operator core through to the MCX server and through to the trackside components as well, one carrying signaling and the other carrying traffic. The advantage of this configuration is it's going to provide protection in the FRMCS 5G system. So if this fails, we've got the 5G system in the public network, and we can set up two parallel connections. So we've got service continuity. The downside, however, is it's a lot more complicated. And of course, we need to set up a form of agreement with the public operator to actually use their infrastructure to support our communications. And then another solution is the so-called 2 onboard radio scenarios. So in this case, we've got 2 radios. They're both equipped with the FRMCS SIM, the Infrastructure Manager SIM, and we can connect to the FRMCS network and, using national roaming, if necessary, also connect through to the public network. So this will protect us against failures in our RAN, in the FRMCS RAN. It will provide service continuity. We might be able to use network slicing to manage the quality of service that we require. And the specifications, the 3GPP specifications, are actually already in place, allowing us to interconnect different 5G networks together. But again, the downside is we've only got one mission-critical application server, so a failure here would be quite catastrophic. And we got, again, further complexity with the onboard